Welcome to the first session of this course called Data. Today's session is very short. It's just an introduction to what is a variable and how do you classify variables. But let me just introduce the course very briefly. The course, as you know, is about data. And data is everywhere. There is no way you can avoid data, whether you like it or not. You look around you, or if you are watching TV, you're bombarded with data. If you're driving on the highway, you'll see billboards everywhere, maybe with the exception of Vermont. They're all in your face, telling you what to do and what not to do. And we have a brain, and we need to use our minds properly to discern good advertising, good data, good marketing from bad ones. And even if it is good, we need to learn how to take the data that is raw, or let's say uncooked, right? And learn how to deal with it to make some good conclusions that can help you with your life decisions. We make, maybe thousands of decisions a day. And oftentimes those decisions are based on data in the back of our head that is stuck in the back of our head, or that we are looking at it, and we need to make decisions sometimes fast. So we should be able to differentiate between good stuff and bad stuff. And if the data is bad, then we just get rid of it. And if it is good, then we have to take an additional step and learn how to organize it, how to classify it, how to graph it. As they say, a picture is worth 1,000 words. So we need to be able to graph it so that we can analyze it properly, so we can make good decisions. Selfishly, if you know how to work with data, and you're interested in making money, you can easily look at data of a particular publicly traded company and read their balance sheets and income statements and cash flow statements, and be able to predict to a high degree what the future would look like in terms of earnings and so on and so forth. And then you can decide whether you should invest in that particular company and make money or not. You could avoid a bad company because you know how to read data. You can invest in a good one because you know how to work with data. But if you don't, you may end up losing a lot of money simply because you're not familiar with how to work with data. So learning how to work with data is relevant, useful, and extremely helpful for all the decisions that we make. Now, as I'm sure you've heard before, the only thing that is constant is change, right? So you look around you, everything is changing. You are changing. Your height is changing. Your mood is changing. The temperature of the room or of the city you live in is changing. The volume of water at a bathtub as you take shower is changing. Everything changes. So it's important to learn how to navigate change, because that is the only thing that is constant. And you just have to live with change and feel comfortable with change and learn how to work with change. Okay? So that's just a quick introduction. What we want to do today is something simple. First, recognize that there are what we call variables, and there are things that we call constants. Things that are constants, there isn't much you can do about them. And there is no need to study constants because they are constants, okay? What we care about is the thing that changes, variables, like temperature, like time, right? And we call them random variables. And the first thing to recognize is variables are of two types. There are the categorical variables, and there is what we call quantitative variables. When you hear the word categorical, sometimes you hear the word qualitative. So these two words can be used interchangeably. This deals with a category, a variable that you can place into a bucket or category, and otherwise it is quantitative. One quick way to test whether a variable is categorical or quantitative. Quantitative variables you can find, let's say, an average for. For example, a quantitative variable, one example is height. You can find an average height. So let's say in your class there are 16 students. You can find the average heights of those students. I'm using the word average loosely here. When you say height, you need to know which height you talk. I'm sorry, when you say average, you need to know which average you're talking about. For now, you know what I mean when I say average. Just add those numbers, those heights of those students, and divide that by 16. And that's what I meant by saying average in this case. So you can find an average of a quantitative variable. You cannot find an average of a categorical variable. Examples of categorical variables are gender, race. You can't find an average race, right? Type of soda. Notice I didn't say number of soda. Number of soda would be here. Type of soda, Pepsi, Coke, Sprites. Size, small, medium, large, extra large, and so on and so forth. Color, red, blue, green, purple. You can't find the average color. So these are categorical variables. And it's a binary. So if it's not categorical / qualitative, it is for sure quantitative. Quantitative variables are, height, weight, shoe size, temperature of a room, let's say. So these are quantitative variables. Now, if you find yourself dealing with a variable that happens to be quantitative, then you need to ask yourself another question. So imagine I'm driving from here and I hit a fork. Somebody told me that this is a variable. And I was like, okay, well, I need to know whether I should go left or right. That's the first thing you need to determine. If the variable happens to be categorical, that's a full stop. So you know exactly where you are. But if the variable happens to be quantitative, then you're driving and you hit another fork. And then once again, you have to go left or right. It is important to know whether your quantitative variable is discrete or continuous. Discrete quantitative variable is a variable that takes integer values. So for example, if I go to your school and I hop from one classroom to another, so your first class I find 16 students, the second class I find 12, and then 20, and then 5. So that's a random variable, happens to be discrete, clearly quantitative. If you find yourself saying the word discrete or continuous, you already know that your variable is quantitative. Makes sense? If you're here, you don't know if you're here or here. But if you're either here or here, you already know that you are a quantitative variable. Put it differently, if I say discrete quantitative variable, I don't have to say the word quantitative. If I just say discrete variable, we know it has to be quantitative. Makes sense? So number of students in a room, that's a discrete variable because it takes integer values. It can go from, let's say, 0, a class of 0, or maybe 1 student, not 0. You wouldn't have a class with 0 students. So let's say you have 1 student, and I'll put it on the number line so you can visualize this. So you can have 1 student, and let's say the maximum number of students you have at your school is 20, let's say. So you could have 1 student, 2 students, 3 students, ... 19 students, 20 students. So this number line from 1 to 20 hops across integers, right? It hops. So that's how you recognize a discrete random variable. And the examples I gave you are number of students in the room, in a classroom, let's say, SAT score, let's say from 200 to 800. You're not going to have 639.56 points, right? So the values only take integer values. Number of cars in a household. Could have 2 cars, 1 car, 0 car, 5 cars. Big households, they have many cars. You're not going to have square roots of 2 cars, right? So these are examples of discrete random variables. The other one, if it's not discrete, it is continuous. It's also a binary here. So the famous random variable that is continuous happens to be time. Time is continuous. Height, yeah, it is continuous. You could have any height between a minimum and a maximum. I wrote the amount of chocolate in a chocolate bar. Take random chocolate bars and look at the amount of chocolate in those bars. Or a famous one would be number of gallons in a gas tank. So you could have, let's say, the minimum, as you know, you could have in a gas tank, minimum number of gallons is 0 gallons. And let's say the maximum is 22 gallons. Okay, so this is your car. It can hold up to a maximum of 22 gallons. You could literally have any amount of gas between 0 and 22. Notice that I didn't lift my finger, my hand, my pencil, right? If it's discrete, it'll do something like this, right? So number of gallons in a tank is a continuous random variable. It takes any value between 0 gallons, which is the minimum, and 22 gallons, which is the maximum. So this is how I differentiate between discrete random variable, like SAT scores, and amount of chocolate in a chocolate bar, let's say, or time. Okay, so that's how you differentiate between the two, visually speaking. I put them on the number line for you. Now, why do we care about knowing the difference, whether it is this difference or if you are here, we differentiate them again. The reason we need to know if your variable is categorical or quantitative, because certain graphs only work with particular type of variables. So for categorical variables, the graphs we associate with those are the ones you're familiar with from, 5th grade, bar graphs and pie charts. So you could put color in a pie chart. You're not going to put color in one of these type of graphs. If you happen to have a variable that is quantitative, actually it does not matter if it is discrete or continuous. You can choose among these graphs. Now, this is not an exhaustive list. I just gave you some examples. So, for example, if I am trying to sketch SAT scores of all students in the U.S., like SAT score and the frequency, like 20 people got 650 and 100 people got 700. If I want to sketch that, I might choose a histogram, for instance. I am not going to do a pie chart. Conversely, if I'm dealing with type of soda, we're not going to do a stem and leaf plots. We're going to stick with one of these two types of graphs. Now, this is not better than this one, and this is not better than this one. They both have pros and cons. Same thing with here. So let's say you have a quantitative variable, say shoe size, okay? Shoe size at your school. So you want to ask every student what is your shoe size, and you want to figure out the distribution of the shoe size. But let's say you are interested in differentiating between shoe size among the girls versus shoe size among the boys. So let's say you have girls, you stratify it by gender. Boys, you're still interested in shoe size, okay? Which means you want to compare shoe size of the boys, the distribution of those shoe size among the boys. 2, shoe size among the girls. You may want to use what we call stem and leaf plots. You may want to use a box plot. These are really good for comparisons, these two. So it doesn't make sense to use a histogram. Well, actually, you could. You could use a histogram to compare as well. You're not going to use an ogive, even though you probably don't know what this means. None of these is better than the other. It all depends on the context. So if you are comparing, these are your best ones, maybe followed by this one, right? If you, let's say you have a quantitative random variable and the data set is large. I don't know, let's say you have 1,000 points, 1,000 observations, not 50, not 4, but 1,000. The sample size is large, or the number of observations is large. It doesn't make sense to do a stem and leaf plot. I know we're not comparing. You could still do a stem and leaf plot or a box plot if you're not comparing. But stem and leaf plot makes no sense when the data is so large, because you're going to end up wasting so much time. You could do it, it's just going to take you a few hours. What you may want to do is split that 1,000 observations into buckets of, let's say, 100. So you'll have a histogram made of 5 towers, and each tower contains 100 points. So all the numbers, let's say, between 0 and 100 belong to one bucket. All the numbers between 100 and 200 belong to a second bucket, and so on and so forth. So histograms allow you to work with large data, because you take that 1,000 points or observations and you split them into literally like buckets. And each bucket will house 100 observations or 50 observations or 200 observations. So that's how it works. So again, none of these is better than the other. It all depends on the context. So this is a very short unit or topic on random variables and their classifications. They are either categorical / qualitative, or they are quantitative. If they are quantitative, you've got to figure out if it is discrete or continuous. All of this is so we know which graphs to use. There are other reasons why we have to split them, but one of the reasons is an obvious one. Which graph should you use? And all of this, why do we care about the graphs, you might ask? Because we want to be able to analyze the observations that we have at our disposal. I'm going to end with very short assignments, and we will call it. We will finish. Okay. So 3 questions. One is, I would like you to look around your home and come up with 5 categorical and 5 quantitative variables. But the only request I have is I want you to think of 5 qualitative categorical and another 5 quantitative. That's 10 total of variables that are meaningful to you. So for instance, if let's say you care about health food, okay? You care about health. And so you may want to open your fridge and pick up 5 items in your fridge, and you might be interested in number of calories within each unit, within each thing that you see in the fridge. So number of calories will qualify as quantitative, right? And then you have to decide if it is discrete or continuous. So if you care about health, maybe that's one of the things you might think of. I don't want you just to give me any 5, any 10, 5 and 5, because you could do that in like 2 seconds. I want you to come up with something that is helpful and meaningful to you, something you're actually curious about, okay? Something you're curious about, even if it is not meaningful to you. The second, that's obvious. I don't have to mention it, but just in case. If your variable is quantitative, I want you to decide whether it is discrete or continuous. That shouldn't take you long at all. And finally, I will never ask this question again. I feel like maybe I should ask the first time just in case. make sure to explain your reasoning for each choice. So if you decide that such and such is a quantitative, it is a discrete random variable, you need to explain to me why it is discrete. Why it is not continuous, okay? So you always have to explain what you write, explain your reasoning. So this whole assignment should take you about, 15, 20 minutes. And so this is probably a good start to the course, and I will see you next time.